So here we're asked to work out 2 1/7 plus 1 1/4. So here we're working with two different fractions, and these fractions are mixed numbers because they contain numbers and then a fraction as well. So when we're adding these mixed numbers together, we can kind of take the number part and the fraction part and work with them separately. So if I look here, we have 2 1/7 plus 1 1/4. So basically, in this calculation, we're going to be doing 2 plus 1 plus 1/7 plus 1/4. And that just helps work it out a little bit more easily because we can take the 2 plus 1, bracket that, and then we can add these on separately. So we can do the 2 plus 1 to get 3. So it's basically going to be 3 plus 1/7 plus 1/4. And now we just need to add 1/7 and 1/4, and then we can leave the answer in the form of a mixed number, 3, and then a fraction. So to add 1/7 and 1/4, these two fractions have different denominators. So we're going to be looking to convert them into a similar form so they have a common denominator so that we can add their numerators. Now in order to do this, we need to find the lowest common multiple. So the LCM of the denominators, so 7 and 4. And in this case, it's just going to be 7 multiplied by 4 because there's no lower common denominator of 7 and 4. So 7 multiplied by 4 is going to be 28. So this is going to be the common denominator that we work with. So I can then take this common denominator, and if we have 1/7 and we need to multiply that by something to get 28, we've multiplied it by 4 over 4. So 1 multiplied by 4 is going to give us 4. And this side's also multiplied by 4. So we have 4 over 28. And then 1/4 is equal to, we've multiplied that by 7. So we're going to multiply the top by 7 as well. And that gets us 7 over 28. So to add 1/7 and 1/4, we're going to basically add 4 over 28 and 7 over 28. And because we've got common denominator of 28 here, we can simply add the numerators, so 7 plus 4 to get us 11 over 28. And then if we look back, we've got this original 3 that we need to add on as well. So the final answer here is going to be 3 and 11 over 28. And that's going to be the answer written in the form of a mixed number. We could convert this into an improper fraction, a top-heavy fraction, but this is still going to get us both of the marks here. We gain the first mark for the majority of the working out, so converting the fractions, and then the final mark for getting the correct final answer here at the end. I'm now asked to work out 1 1/5 divided by 3/4, and I'm also asked to give my answer as a mixed number in its simplest form in this question. So firstly, I can see here that in the question I have a mixed number, and I'm going to be dividing this by just a normal fraction. So it's probably a good idea here to start by converting this mixed number into a simple fraction, which in this case is going to be an improper fraction. So if we have 1 1/5 and we want to convert that into an improper fraction, if we have a integer of 1, we have basically 5 over 5. So that's going to be 1. And then we can add on this 1/5 as well, and that's going to get us 6 over 5. So 1 1/5 is basically equal to 6 over 5, and that's an improper fraction. And so now we have 6 divided by 5, and that's going to be divided by 3/4. Now when we're dividing a fraction by another fraction, we can just multiply this fraction by the reciprocal of the second fraction. So 1 over whatever the second fraction is. So that in this case is going to give us 6 divided by 5. And then we multiply that by the reciprocal of 3/4. So we swap the denominator and the numerator, and we get 4 over 3. And now we've got a simple multiplication to work with, and when we're multiplying two fractions, we can just multiply the numerators and the denominators separately. So 6 multiplied by 4 is going to be over 5 multiplied by 3. So that leaves us with 24 over 15. Now, if we look back to the question, it's asked us to give our answer as a mixed number. And here we have our answer as an improper fraction. So we're going to have to convert this improper fraction into a mixed number. Now, if I look at how many lots of 15 go into 24, we have one lot of 15 and then a remainder which is going to be 24 minus 15, and then that's going to be over 15. So that's how we're going to convert this improper fraction back into a mixed number. So we have one lot of 15 and then this remainder of 9, which is going to be out of 15. So 1 and 9 over 15. And we also need to check that this is in its simplest form. So do 9 and 15 have any common factors which we could use to simplify the fraction? And yes, in fact they do have a common factor, which in this case is going to be 3. So if we divide the top and the bottom of the fraction we have here by 3, we're going to be left with 1 and 3 over 5. And that is going to be the correct answer and gain us the second mark, which is for the answer. And then the first mark is going to be for the working out and the correct working out stages throughout this question. So here I'm told that in a village, the number of houses and the number of flats are in the ratio 7:4. And we also are told that the number of flats and the number of bungalows are in the ratio 8:5. We are then told that there are 50 bungalows in the village, and we're asked how many houses there are in the village. So with a ratio question like this, we're working with a couple of different ratios between a couple of different places. So it's a good idea to kind of get them all into the same place and write them out in a little bit of an easier way to comprehend and see instantly. So if I write out that we have houses to flats, and we can see at the start of the question that this ratio is 7:4, so 7:4. And then here I can see that we have flats mentioned again, but this time they're in a ratio with bungalows. So if I write this out beneath it, we have here flats in the same column as flats were before to bungalows. And then this ratio was 8:5. And since we're told that there are 50 bungalows in the village and we're working out how many houses there are, we're looking at the houses and bungalows here, and we're going to be looking at the ratio between these, and we can use the number of flats in each ratio to work out the ratio between the houses and the bungalows to then work out how many houses there are when there are 50 bungalows in the village. So here I can see that between the 4 flats and the 8 flats in these ratios, this ratio between houses and flats can be multiplied by 2 to get a ratio between houses and flats in which flats are going to be the 8 here. So we can multiply this by 2. Just multiplying up the ratio by a factor doesn't affect the ratio, it's just not in its simplest form anymore. So we can multiply both of these sides of the ratio up by 2. And now I'm going to have an answer of 14 to 8. So the ratio of houses to flats, 7:4, can just be rewritten as 14 to 8. And then we have the ratio of flats to bungalows, 8:5. So now we can simply add in the bungalows, which is still, if when there's 8 flats, there's 5 bungalows, like so. So now we have a ratio of houses to flats to bungalows, so 14 to 8:5. So then the ratio of houses to bungalows, in this case, we can just read off, taking out the 8 of the flats, we have as 14 to 5. And we are told that there are 50 bungalows in the village and asked how many houses there are. So now we can just scale up this ratio. So if we have 14 to 5 and we want 50 bungalows, we need to take this ratio and multiply it by a factor of 10. So we've done the bungalows side, and now we're going to do the houses side, and that's going to give us a ratio of 140 to 50. So when there are 50 bungalows in the village, there are going to be 140 houses. And there we've answered the question. So there are going to be 140 houses in the village. And we've gotten the marks here, firstly, for working out this first ratio. So basically relating houses to bungalows in this ratio here. And then the second mark is going to be for multiplying it up by a factor of 10 to see how many houses there are going to be when there are 50 bungalows. And then the third mark is for stating the correct answer of 140 houses here in this instance. Here we're told that Renee buys 5 kilograms of sweets to sell and that she pays £10 for these sweets. We're also told that she puts all of the sweets into bags and she puts 250 grams of sweets into each bag. And then she sells each of these bags for 65 pence. And we're also told that she sells all of the bags of sweets, all being an important word here. And we're asked to work out her percentage profit, so the percentage profit that she made by selling these sweets if they cost her £10 to buy. So with questions like this, we're given quite a lot of information. So I always find it really useful to go back and look through it and then write out any of the key facts that we need to know. So I can see at the top that we have 5 kilograms of sweets, so 5 kilograms cost her £10 to buy. We then have, she puts them in bags of 250 grams and they are then sold for 65 pence. And then we're looking to work out the percentage profit from this, so that's all of the key numerical information that we are given. So initially here I'm realising that we're working with a couple of different units. So we have this value in kilograms and this one in grams. So it's going to be useful to convert these into the same form, and it's probably going to be easier to convert them both into grams here to avoid having any decimals. So I could do this already. So if we have 5 kilograms, to convert that into grams, we're going to multiply it by 1,000 because it's 1,000 grams in a kilogram. So 5 kilograms is going to be 5,000 grams, and then that's going to cost her £10 to buy. Similarly here, we have one of the prices in pounds and then one in pence. And again, it's probably going to be easier to convert into pounds here because pence is going to be a bit tricky to work with because we're going to have such large numbers. So if I take 65p and we want to convert that into pounds, we divide it by 100 because there's 100 pence in a pound, and that gives us basically 0.65 pounds. So 65 pence, just written in pounds, it's a bit easier to work with for us. So initially here, I'm going to start this question by working out how many bags of sweets she sold. We need to work out how many bags she sold to work out how much she made, how much money she made from selling these bags. So if she has 5,000 grams of sweets and each bag has 250 grams in, to work out the number of bags sold, we're going to take this 5,000 and divide it by 250. So how many lots of 250 gram bags can go into 5,000? And 5,000 divided by 250 is going to give us an answer of 20 bags. So she's sold 20 bags of sweets. And now we can work out the cost of these 20 bags of sweets to work out how much money she has earned from selling these sweets. So we take the cost of one bag of sweets, which is 65 pence, which we converted into 0.65 pounds. And then we can multiply that by these 20 bags. So how much did 20 bags cost? And that gives us an answer of £13. So basically, she sold her sweets and earned £13 from it. She's had £13 given to her for these 20 bags of sweets. We can now go on a bit further and see how much profit she's made. So if she has made £13 and spent £10, the profit is going to be equal to the difference between these two. So in this case, we're going to have 13 minus 10. So she's made a profit of £3. And we're asked to work out her percentage profit here. And the way of doing this is going to be by taking her profit, so the numerical value for the profit, dividing it by the cost, so what she spent, and then multiplying that by 100 to turn it into a percentage. So in this case, we're going to have the £3 profit, which is out of an original £10 that she spent on the sweets. And then we multiply this up by 100 in order to get this as a percentage. And once we calculate this, we're given an answer of 30%. And that is going to be the value of her percentage profit. So the percentage profit she's made on the original £10 she spent on sweets. And that's going to bring us to our final answer, which is the 30% that we've calculated here. So if I go back and look at how the marks were awarded, firstly, we have the mark for working out the number of bags sold, so the 20 bags. And it's always a good idea to kind of write out what we're doing in each step. So we have bags sold here and then the cost of the 20 bags, just so it's really clear what we're doing along the way. The second mark's then going to be for working out the cost of these 20 bags, so £13. And then using this to work out the difference, the profit, and then basically calculating the percentage profit here. And then the final mark is an answer mark just for getting the final correct answer of 30% here. So here we have that a cycle race across America is 3,069.25 miles in length, and Juan knows his average speed for this previous races is 15.12 miles per hour. And we're told that for the next race across America, he will cycle for 8 hours per day. And we're then asked to estimate, being the key word here, how many days Juan will take to complete the race. So a really key point here is that we're working with an estimation of the number of days. So we're not going to be actually calculating the exact number of days. We're going to be using rounded values and values that are going to be easier to work with to work out these number of days. So to start here, I'm going to start by rounding these values to some sensible kind of numbers that are going to be a lot easier to work with and provide a good estimate for me. So, if I take the 3,069.25 miles, a sensible estimate for this would be something probably to one or two significant figures, but because this number is so close to 3,000, I'm just going to round it down to 3,000 miles. It's a really nice whole number and it's going to be really easy to work with later on in the question. We also then have 15.12 miles per hour. And similarly here, this is very close to a whole number, very close to 15. And if I look at 3,000 miles and 15 miles an hour, these are really nice numbers that are going to work well and work together in these calculations. So I'm going to round this one to 15 miles per hour. I know the average speed and I know the distance, and I'm looking for time so that I can work out how many days it's going to take. So if I get my speed, distance, time triangle to work out how to calculate time, so we have distance and then we have speed and time at the bottom of the triangle, like so. And if I want to calculate time in this instance, I simply do distance and then divide that by the average speed in this case. So the distance I've rounded this distance to a distance of 3,000 miles, and then I'm dividing that by the speed, the average speed, which I've rounded to 15. And these numbers are going to work really nicely together, so we know we've chosen good estimates for these. So then I can take this and calculate this, and it comes out as an answer of 200. And the units here, if we have miles here and then miles per hour, the miles cancel out and we're basically left with 200 hours. We then need to work out how many days this is going to take one, and if he is doing 8 hours of cycling per day, then we can simply take this 200 and divide it by 8 to work out how many days it's going to take with 8 hours of cycling each day. So 200 divided by 8 is going to give us an answer of 25. So 25 days is what it's the estimated value that it will take to complete this race. And that's a good estimate. We could have used different numbers throughout the question. You could change them slightly and still get to a reasonably similar answer, but we need to make sure that we do estimate this and don't calculate it accurately, because we would not obtain the marks here for that. So the marks are distributed firstly for basically doing the time calculation, so the 3,000 divided by the 15, or some similar values, so some kind of distance over speed. And then the second mark is for dividing this down by 8 to work out how many days it should take if we're doing 8 hours of cycling a day. And then the final mark is for a correct final answer, which it could be a range of different things depending on which input values you've used. I'm now told that Juan trains for the race. The average speed he can cycle at increases, and it's now 16.27 miles per hour. And we're asked, how does this affect your answer to part A of the question? So in order to work this out, I'm going to go back and have a look at the equation that we used. So I used the fact that time is equal to distance over speed. Now we're told here that the average speed, so the speed, the S in this equation, is going to increase after his training. And an increase in speed, in this instance, is going to cause a decrease in time, because time and speed are inversely proportional. So time's proportional to 1 over speed. So as speed increases, time's going to do the opposite and decrease. So if less time is taken to complete this race, and in the previous part of the question we were working out the number of days it would take, doing 8 hours each day, if less time's taken when dividing this by 8, we're going to require less days to complete the race. So to get the mark here, you simply need to write the fact that less days are required. There's no explanation needed here, but it's always good to understand the reasoning behind the answer and see how this works, linking back to the equation. Alternatively here, we could have gone down the estimate route and said that 16.27 could still be rounded down to 15, like we did in the previous part of the question, and because we're working with estimates, this wouldn't actually affect our answer. That would also gain us the mark here. So either way, going about this question would gain us this single mark and bring us to the end of this question. So here I'm showing a solid square-based pyramid, which is the diagram below. And I'm told that the base of the pyramid is a square of side 6 centimetres. So I can see that here, this length is 6 centimetres, and then this length, and this length are also all 6 centimetres because the base is a square. I'm then told that the height of the pyramid is 4 centimetres. So I can see that this line here from the centre of the base to the top of the pyramid, point V, is going to be 4 centimetres, that distance there. And finally, I'm told that M is the midpoint of BC and VM, and it's equal to 5 centimetres. So this is BC, and then VM, the line, is going to be equal to 5 centimetres, and M is this midpoint on BC. So we're then asked to draw an accurate front elevation of the pyramid from the direction of the arrow. So this is the direction we're going looking at the pyramid in this direction, and we're asked to draw what it would look like. So we're basically going to be seeing one face of this shape. We're going to be seeing the front face. And I know that the length of the base here is going to be 6 centimetres, and I'm going to see this. This is going to be at the bottom of the front elevation. So I can draw a 6 centimetre line at the bottom, and if I take each small square to equal 1 centimetre, we have a 6 centimetre line here. I can label that one up. And then if I look at the diagram, looking from this direction, this face and the face obscured here, as well as the back face, are all going to be obscured by this front face that we're looking at. So at the front, in the front view, we're simply going to see this triangle here, AVB. That's all we're going to see looking at this square-based pyramid from the front. So we're basically going to be looking at a triangle. Now the height of the triangle isn't going to be this 5 centimetres, that's a diagonal height across this distance. It's going to be this 4 centimetres here, which is the distance V is from the line AB vertically. So V is 4 centimetres vertically above the line AB. And V is going to be halfway in between A and B horizontally, so 3 squares in between. So I can mark that point up. And then it's going to be 4 squares above. So 1, 2, 3, 4. This is the point where V is going to sit. And then I can just attach these points to this top of the triangle. And it's going to leave us with an isosceles triangle. So this length down the centre is going to be 4 centimetres. So it's an isosceles triangle that we will see with a base length of 6 centimetres and then a height of 4 centimetres. And that's going to gain us both of the marks here for understanding that it's going to be a triangle firstly, and then for getting the correct side lengths and orientation of the triangle. And now I'm asked to work out the total surface area of the pyramid. So I can see from the diagram, this pyramid is made up of its square base, so this face which is on the bottom, and then 4 identical triangular faces, which are all going to have the same area. So the surface area here is effectively one lot of the square base, and then we're going to be adding on 4 lots of these triangular faces because there are 4 triangular faces. And then I can start here by looking at the square base, as it's going to be easier to work with. It's AB is on length 6, BC is also 6 centimetres, they're all going to be 6 centimetres. So the area here is simply going to be 6 multiplied by 6, and that gives us an area of 36 for the base. And now we need to add on 4 lots of the area of one of the triangular faces. So if I redraw the diagram of one of these triangles, I can then take the base length, so 6 centimetres here, and then this length of the triangle. Now this isn't going to be the height of the pyramid, it's not going to be this 4 centimetres, it's going to be the distance between the top of the triangle and the midpoint on its base, so the distance VM, which we're told is 5 centimetres. So I now know that this one's 5 centimetres. Now the area of a triangle is going to be a half base times height, and in this case it's going to be half times the base, which is 6, times the height of the triangle, which we've calculated to be 5. And that gives me an answer of 15. So now I have the area of the square base and an area of one of the triangular faces. I can simply add them together. So I have the 36 for the square base, and I'm going to be adding on 4 lots of these triangular faces, the area of that. So 4 times 15, and that's going to give me 36 plus 60, which gives me a final answer of 96. Now this question is worth 4 marks here, so it's going to require quite a bit of working out. And as we can see, in the question, we are given the units for each of the lengths. And there's no units predetermined in this question. So in order to obtain the last mark, we're going to have to work out the units. And we're working with area, so surface area, and that's going to give us a unit of something squared, and here we're working with centimetres, so I've done 6 times 6 centimetres multiplied by centimetres, which is effectively what I've done, is going to give me the unit of centimetres squared, which is the unit for area in this case. So to give my final answer and gain all 4 of the marks, I'm going to write 96 centimetres squared. So if I go back through and see exactly where I picked each of the marks up individually, the first mark would be for working out the area of one of the triangular faces, so getting that 15. Secondly, for then working out the total surface area, so by taking the 4 multiplied by 15 and adding on the 6 multiplied by 6 to get this surface area for attempting that. And the third mark's for obtaining the correct answer of 96, so this numerical answer here, that gets me the 3rd mark. And then the final mark is for the units. Putting the units on the end, the centimetres squared, gains the 4th mark in this question. So here we have a pattern which is made from 4 identical squares, and we're told that the sides of these squares are parallel to the axes. And we can see that in the diagram below. So we have these sides of all of the squares which are going to be parallel to the y-axis here, and similarly these sides of the squares which are parallel to the x-axis. If we then go on, we're told that point A has coordinates 6, 7, and we can see point A here on the diagram. It's in the bottom left corner of the bottom left square of the diagram. And we then have point B, which is at 38, 36, which is at the top right corner of the top right square of this diagram. So these 2 points are the furthest away they could possibly be on this diagram. They're on opposite corners of the pattern, on as far away as they can be while touching the squares. We're then told that point C is marked on the diagram, and we're asked to work out its coordinates. So point C is here in the centre of the diagram. Now initially here, I'm thinking we're working with these 4 squares, which are all identical, and we can work out the distance between points A and B, and we could use this to figure out the side length of these squares, because we're going to need to know the side length to work out where C is in comparison to the coordinates of A and B. So we could either do this by looking at the x-axis or at the y-axis, but here I'm going to take the x-axis as my example. So I want to work out the side length of a square. So if we look across the x-axis, point A rests here at 6, and then point B, we trace that down, we're going to be at the x-coordinate 38. Now in between A and B, if we go across the x-axis, we have 4 complete squares, 4 complete side lengths of this square. So if we take the difference between these x-coordinates and divide it by 4, we're going to get the side length of 1 square. So I can take the difference by doing 38 minus 6, which gives me 32. And then I need to take 32 and divide that by 4 to give me 8 for the side length of 1 square. So each of these lengths are going to be 8. And because they're squares, we also know the vertical lengths are going to be 8. So this length here. Now we can use this to work out both the x and y coordinate of point C. So I can see that point C is going to be 2 complete side lengths away from point A and point B if we're going on the x-axis. So if I take the x-coordinate of point A, which is 6, I can then work with this. So I'll take the 6 and I now need to add on 2 lots of 8 in order to go across the x-axis to get to the point C to find C's x-coordinate. So I'm doing 6 plus 8 and that's going to give me 22. So I've gone from point 6 across 8 and across another 8 and that gives me the x-coordinate of C, which is at 22. So I can write that in the box as I've already calculated the x-coordinate of 22 here. Now similarly, for the y-coordinate of C, if I look at the diagram again, from point B this time, if I go down 2 complete squares, 2 complete side lengths, I'm going to get to the y-coordinate of point C. So I need to take the y-coordinate of point B and subtract 2 lots of 8, so 2 side lengths from that. So the y-coordinate of point C, I'll take the y-coordinate of B, which is 36, subtract 8, and subtract another 8, and that's going to leave me with an answer of 20 here to put in as the y-coordinate. So now if I go back and have a look at how the marks were awarded, the first mark here was for finding the width of the diagram, so the width of these 4 squares by doing 38 minus 6 to get 32. Similarly, I could have found the height to get this mark, but working with the width just seemed a little bit easier in this case. I then get the second mark for dividing this by 4 to find the side length of 1 square. And the third mark would have been for then calculating the x-coordinate correctly using this side length of 8. And the following one for finding the y-coordinate correctly from counting down from the y-coordinate of point B. And then the final of the fifth of the 5 marks is going to be for the final correct answer given in the box as 22, 20 for the coordinates of C. So here we're told that shape T is reflected in the line x equals minus 1 to give us shape R. And then shape R is reflected again, but this time in the line y equals minus 2 to give a new shape S. And we're then asked to use this information to describe the single transformation that will map shape T, so the original shape, to shape S, which is the last shape that we're going to work out. So then if we have a look at the diagram, we have obviously shape T here, which is a triangle. And we need to work out how it's going to be mapped to shape S in a single transformation. Now firstly we need to assess where shape S is going to be, and in order to do that we're going to have to do both of the reflections, find where shape R is, and then use this to find where shape S is, and then we can look at the transformation between T and S. So whenever we're working with a reflection, I always find it useful to draw in the line that we're going to be reflecting it on. So firstly, shape T is reflected in the line x equals minus 1. So if I take x being equal to minus 1 and draw in this line, and I'll label it up as well just so that I'm 100% certain which line this is, I can then reflect T in it. So this point here is going to be 2 squares away from this line. So when it's reflected, it's going to be 2 squares on this side. This point here is 2 further away, so 2 further away. And then finally the top point is going to be 3 squares away from the line, so 3 squares to this side of the line. And then I can redraw in the lines, and that will leave me with my shape. And then I can label this one up as R. So T's been reflected in the line x equals -1, and that's given us shape R. Now moving on to shape S. Shape R's reflected again, but this time in the line y equals -2 to give us shape S. So if I draw in the line where y equals -2, and just label that up, I can then reflect R in this. So these points are 3 squares away from this line. So if we continue 3 squares down on each side, we're left there. And then this top point is going to be 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So that's going to rest here. And I can draw that in, and then draw the shape in. And this one is going to be shape S. Now we're basically looking for the relationship between T and S and the single transformation. So one transformation, we can describe this in one transformation, which maps T to shape S. Now initially here, I can see that T is a triangle facing this way up, so the top's pointing upwards, whereas S, the top is pointing downwards here. So initially here I'm thinking about some kind of rotation that may have taken place. So an 180-degree rotation would take T to S. Now I need to find the point at which this rotation is going to be from. Now we have these two lines that the shape's been reflected over. And if I look at this point here, where these two lines intersect, we're going to see that if we were to rotate T, so this triangle, 180 degrees clockwise or anti-clockwise, it doesn't matter, either way, for about this point here, so this centre, then it is going to be mapped to point S. So rotating T 180 degrees about the point -1, -2 is going to map it to S. And then that's the single transformation that we've been asked to find here. So in order to get both of the marks, one of the marks is going to be for saying there's a rotation of 180 degrees. And then the second mark is going to be for stating the point. So it's about the point -1, -2. And we need both of these points to get both of the marks here. So one is going to be for each. And that brings us to the end of this question. Quite a bit of working out and drawing on this graph in order to work out the transformation and just to be 100% sure that that is what has gone on here and what has happened. Alternatively here, we could have gone about this in a different way, and instead of working with rotation, we could have used enlargement. So in this instance, we would have ended up with an enlargement of a scale factor of -1, so that would get us the first mark, and then yet again about the centre -1, -2, and that would gain us the second mark here. So there's a couple of different ways you could go about this question, either using the rotation or the enlargement. Both are going to get you both of the marks here. So here I'm told that the perimeter of a right-angled triangle is 72 centimetres. And I'm also told that the lengths of its sides are in the ratio 3 to 4 to 5. And I'm asked to use this information to work out the area of this triangle. So I think a good place to start here would be just drawing a quick diagram out, just so that I can definitely see what's happening. I know that I'm working with a right-angled triangle with sides in the ratio 3 to 4 to 5, and the greatest length, so this one represented by the 5 in the ratio, is going to have to be the diagonal of this triangle, as that's going to have to be the longest length. So if I draw out a triangle like so, we can see that this longest diagonal length is going to have to be the greatest one, and then the two side lengths are going to be represented by the 3 and the 4 in the ratio. So I can just start by labelling the sides of the triangle up with the values in the ratio. So if we go 3 to 4 to 5. And so we have a base triangle to work with here. Now we're told that the perimeter of the triangle is 72 centimetres. So there's got to be a way we can scale up this ratio of 3 to 4 to 5 to have these side lengths sum to 72 centimetres to be the perimeter of this triangle. So if I take 3 and add on the 4 and the 5, that's going to give us a value of 12. And then I can take the 72, which is the perimeter of the actual right angle triangle, and divide it by the perimeter of this triangle that I have here to see how much each side length needs to be scaled up by to get to the right angled triangle with a perimeter of 72 centimetres. So this here gives me an answer of 6. So now I know that each side length of this triangle has to be scaled up by a factor of 6. And in order to work out its area, I need to take the base length, so this length here, and multiply it by this length here, and then divide that answer by 2. So if I take the 4, now that's going to be multiplied by 6 to get the actual length, so that gives me an answer of 24. I can then take the 3 as well, multiply that by 6 to get the new length, and that gives me an answer of 18. And now I have the two side lengths that I need to work with of the new triangle. So to work out the area here, I'm going to take 24, multiply it by this 18, and then I need to divide that by 2 to find the area of the triangle. And that is going to give me an answer of 216. And as for the units here, we can see that we're working with centimetres squared, and we can just check this because we know that each side length is now going to be in centimetres, and we're multiplying centimetres by centimetres, so that's going to get us centimetres squared here. Now I can simply write my answer in the box, and that is going to gain me all 4 marks for this question here. So if I have a look back through how the marks were awarded, so the first mark was for working with the ratio and finding this value of 6 by which they all need to be multiplied up by in order to achieve the side lengths of the actual triangle, not the kind of scaled down version shown by this ratio in its simplest form. And then the second mark here is for finding the length of either the base or the height of the triangle, so one of these, either this calculation of 24 or the calculation of 18 here, will get me the second mark. And then finally this last step of working out the area of the triangle, so using the formula base times height divided by 2, that's going to get me the third mark. And then the fourth and final mark here is just awarded for the correct final answer of 216. So firstly here, I'm asked to write down the value of 36 to the power of a half. Now, I'm noting here that the question is simply asking me to write down this answer. It's only worth 1 mark, so it's not going to require any sort of calculations or working out. It's going to be quite an easy question just to state the answer to. So if I'm working with a number to the power of a half, I'm thinking back to my laws of powers, and something to the power of a fraction to the power of a half is basically the same as saying that we're square rooting whatever the number that we're raising to the power of the half is. So it's the power of 1 over 2, so we're going to be square rooting this number, so square rooting 36, and that is going to leave us with an answer of 6, which is the square root of 36. So similarly here, I'm again asked to write down, so it's again not going to take any working out, the value of 23 raised to the power of 0. So here again, I'm thinking back to my laws of powers and how powers are going to work. And I'm remembering that when any number is raised to the power of 0, the answer is just going to get me 1 every time. So x to the power of 0 is always going to equal 1. So 23 to the power of 0 is going to be 1. And this is kind of just a fact that you're kind of required to remember. There's no real way of working through this and working it out. But as long as you remember that any number raised to the power of 0 is 1, then that's going to get you the mark here. So now finally, I'm asked to work out the value of 27 being raised to the power of minus 2 over 3. Now this question's worth 2 marks here, so it's going to require a bit more thought and calculation than the previous parts, because we're raising the number to a bit more of a complicated power here. So again, I'm going to start by thinking back to my laws of indices, my power laws, and working out a way of simplifying this down so that I'm not raising 27 to such a complicated power. So a way of doing this is going to be by splitting down the power. Now, if I raise a power to another power, that's basically the same. I can simplify this by multiplying the 2 powers together. So for example, if we had k to the 3 and that all being raised to the power of 2, I could simplify this down to k to the 3 multiplied by 2, so k to the power of 6. Now this indice law is going to come in really useful here, because I can take this minus 2/3 and split it down into some easier to work with fractions and numbers, so that I can calculate the value of 27 to the power of minus 2 over 3. So initially here, I'm thinking that I'm going to be working with fractions which are multiples of a third. So if I were to take 27 and raise it to the power of a third, I would then have to take this whole thing and raise it to the power of minus 2, because then the minus 2 and a third would multiply together to get this power of minus 2 over 3. And then this is going to be a lot easier to work with. So if I take 27 to the power of a third, similarly to before, raising something to a power of a fraction of 1 over something, I'm just going to do the denominator as a root for 27. So this is going to be the cubed root of 27. And then I'm going to raise that to this power of minus 2, which I'm just going to carry down from the top. So here we have the cubed root of 27, and then that's going to be raised to the power of minus 2. And the cubed root of 27 is going to be 3, so 3 to the power of minus 2. Now, here I could split 3 to the power of minus 2 down even further here. So I could take this as 3 to the power of 2 and then raise that to the power of minus 1, if that makes it a little bit easier to comprehend and work with. Or I could similarly do 3 to the power of minus 1 and then all of that to the power of 2. Either way around works with questions like these. It just depends what feels a bit easier. So if I do 3 to the power of 2, that gives me 9, and that's going to be 9 to the power of minus 1, as I can see I've written out here. And 9 to the power of minus 1 is the same as taking 1 over 9. So raising something to a negative power is taking 1 over that. I could have just done this in one step, so to the power of minus 2 would take me down to 1 over 3 squared, and that would also get me an answer of a 9th. But either way, however works best in your mind, works well here. So the answer is going to be 1 over 9. Now, as for how the marks were awarded here, the first mark would be for working with a cubed root somewhere in your answer. So that would be how I would get the first mark. Alternatively, if you'd gone about this in a different way, it could have been working with the reciprocal, so something to the power of minus 1 and doing 1 over that. That would have alternatively gotten us our first mark. And then the second mark is for the correct right answer at the end of this question. So here we're told that this table gives some information about the heights of 80 girls, and then we have the information here. So we have the least height, which is 133 centimetres, the greatest height, so between those two are the range going from the greatest to the least. We have the lower quartile, so the bottom 25% are below this height of 145 centimetres. The upper quartile, which the top 25% are taller than. And then we have the median, which is basically sits between the quartiles. It's halfway, it's basically the middle height. So half the girls are taller and half of the girls are shorter than 151 centimetres. And I'm then asked to draw a box plot to represent this information, and I'm given a space to do that. So I have the heights along the bottom on this axis, and I basically need to draw in a box plot which shows the information that I've been given in the table. So here I'm looking at the information and I'm thinking about the kind of general way a box plot is drawn. So it's going to have the main box in the centre, and this box is going to have lines at the lower quartile, the median, and then the upper quartile contained within this box. And then there's also going to be the tails or the whiskers of this box plot, which are going to represent the values that don't lie within the interquartile range. They don't lie between the lower and upper quartiles, and these are going to extend out to the lowest and greatest heights, and that's going to show the range. So if I start here with the least height, which I have as 133 centimetres, now this is going to be one of the tails of the box plot. So I could draw in a line for at 133. And that's going to be the bottom end, the bottom tail. And then similarly for the greatest height at 170 centimetres, this is going to be at the other end, so the other tail or the other whisker at 170 centimetres. So I can draw that one in as well. And I'm going to draw all of the vertical lines in before I attach them all together, just so that I can see exactly what's happening with the box in the centre. So then I can draw the centre box in. So if I take the lower quartile at 145 centimetres and the median at 151. It's important to remember here that the median doesn't need to be halfway between the lower and upper quartile. We're going to see this in the diagram. But then we also have the upper quartile at 157 here. Now these centre three lines can be joined together to form this box in the centre of the box plot. And then I'm going to attach the two tails to this box, and these show the range of the data. And that is a box plot with all 5 lines that I need to include, so the 5 pieces of data in the table, and that's going to get me all 3 of the marks here, as it's plotted fully correctly. Now if I'd have plotted 2 of the points correctly, so the whiskers are all part of the box, I would have gotten the first mark. For plotting 3 correctly, that would give me the second mark, and for having them all correct gives me all 3 marks for this question. And I'm now asked to work out an estimate for the number of these girls with a height between 133 centimetres and 157 centimetres. So if I refer back to the box plot that I've just drawn, at 133 centimetres, that's going to be this lower bound, so the shortest, the smallest height. And then up to 157 centimetres, that's here at the upper quartile. So we're basically asked to estimate how many girls have a height between the lower end of the range, so the bottom end, the whisker at the lower end, the tail, and the upper quartile. Now if we break this down into sections, so between the lowest value and the lower quartile, this is going to have 25%. of all of the girls' heights. So 25% of the heights are going to sit in this section, so a quarter of the total heights. And then yet again, between the lower quartile and the median, there's going to be another 25%. Between the median and the upper quartile, another 25%. And then between the upper quartile and the top end of the range, another 25%. So that's how the upper quartiles and the quartiles and interquartile range work. So there's 25% of the data is going to sit in each region. Now, if we're effectively looking for the number of girls' heights which rest between this point and this point here, we're going through 75% of this data in total, so 3 lots of 25%. And if there were 80 heights in total, we can take this 80 and multiply it by 75%, or 3/4, so 3 lots of a quarter. And that's going to come out with an answer of 60. So there are going to be 60 girls with a height between 133 and 157 centimetres as an estimate here. So that's how we'd go about this question. We'd get the first of our marks for basically multiplying by 3/4 or 75%, and then the second for coming to the correct final answer of 60 here. So here I'm told that points A and B are points on the circle with centre O. So I can see here that A and B both sit on the circumference of this circle, which has a centre here of O. I'm also told that BC is a tangent to the circle. So this line BC is going to be tangent. And if we could continue this line, and it's only ever going to touch the circle once here at point B. We're then told that AOC is a straight line. So this line running through the circle is a straight line. It touches the circle on the circumference at point A and then over here. And it also runs through the centre of this circle, which might come in important later in the question. And we're finally told that angle ABO is equal to x. And I can just draw that in because it's probably going to be useful for this question. So if I draw in the line OB, which is going to be the radius of the circle, and the angle ABO, so this angle here, is going to be x degrees. And it's always important to label up your diagrams and just make sure you're 100% certain on where everything is and how everything works. So I'm then asked to find the size of the angle ACB in terms of x. So I'm just going to label up the angle ACB, which is this angle here, and that's the angle that I'm trying to find in this question. I'm asked to give my answer in its simplest form and to give reasons for each stage of my working, so clarifying why I'm doing certain things and why I can do them. So linking back to circle theorems and that kind of thing, this is going to get me a couple more marks for this question, as it is out of 5 marks, so there's going to be some marks for the calculation and then some marks for the reasoning behind it. So initially here, I'm thinking about which angles I'm working with. So if I have the angles given in the diagram, and I need to find this angle here, I can see the triangle ABC is going to come in quite useful. So if I were able to find out this angle here and this angle here, I could simply subtract them from 180, because there's 180 degrees in a triangle, to leave me with this angle here, which is what I'm looking to find. So if I start by looking at this angle here, so angle ABC, I already know that the line BC is going to be tangent to the circle, and I have the line here OB, which is the radius of the circle. Now linking back to my circle theorems, I know that the tangent to a circle is going to be perpendicular, so at a right angle to the radius of this circle. So therefore I know that OB, the line OB, the radius of the circle, is perpendicular to, and that symbol just means it's perpendicular to the line BC, which is tangent to the circle. So I have a right angle here, and I can mark that in on the diagram here. So this angle here is going to be a right angle, and therefore I now know the total angle of ABC because I've got both this segment, the X part, and then the right angle here. So I have this total angle. So therefore the angle ABC is going to be equal to X, add on the 90 for the right angle, and that's going to give me the angle ABC, which is going to be very useful in this question. And then if I'm going to work out all of the angles in the triangle, I also need to work out this angle here, so angle OAB. Now, we have the line AO and the line BO, and they're both the radius of the circle, and that means they're going to be equal to each other and equal to the radius. So if I take AO is equal to BO, and it's equal to the radius of the circle. And now I can have a look a bit further and see that this forms a triangle here. So the lines AO, BO, and then the line AB. Now AO and BO are equal, so this means that triangle AOB is going to be isosceles. And this is also going to prove very useful because thinking back to how I work with triangles, I know that the base angles in an isosceles triangle are going to be equal to each other. And that's going to prove very useful here because this angle and this angle are the two base angles of the triangle. So therefore, the angle OBA, which is equal to X, is also equal to the angle OAB. So OAB is also going to be X, and I can mark that in here. So now I've found the angle OAB and the angle ABC, and these join together with the angle BCA to make a complete triangle. And I know that angles in a triangle are going to always sum to 180 degrees. And I can use that fact here to take 180 degrees. So this is to work out the angle ACB is 180 degrees minus the angle CAB minus the angle CBA. And that will just leave me with this final angle that I'm trying to work out. So 180 minus the angle CAB, so that's just the X that I've calculated in the previous step. And then I'm going to subtract the angle CBA, and I calculated this one to be 90 plus X, so subtracting 90 plus X, and that's going to leave me with a final answer of 90 minus 2X. And that is going to be the answer to this question. So the angle ACB is going to be 90 minus 2X in its simplest form. Now if I look back through the question just to see how the marks were distributed here. So the first mark was for finding the angle, an unknown angle. So either way, I would have gotten the mark here for finding the angle ABC, but if you'd have found a different angle beforehand, then that's fine, that would have gotten you that first mark. Then we would go on and we'd get another mark for basically using this final fact and subtracting the two angles from 180. That would get us a second mark. The third mark would be for the final correct answer, so 90 minus 2x. And then the last 2 marks, because this question's out of 5 marks, would be for the kind of explanation, the points that we've used here, the reasons to back them up. So, for example, saying that the tangent to a circle is perpendicular to the radius, that would give me a mark. And then either saying that angles in a triangle sum to 180, or that base angles in an isosceles triangle are equal would get me that next mark. And then that would leave me with all 5 marks. So there's 2 marks for the reasoning, 2 for the working out, and then 1 for that final correct answer here. So it's really important to, as we're going through the question, write out why we're doing certain things and how we know we can work with angles in this certain way. So here I'm asked to prove that the square of an odd number is always 1 more than a multiple of 4. And this question's worth 4 marks and it's a proof-based question, so I'm going to be looking to structure my answer really logically here, going through the steps and explaining what I'm doing and how I come to my conclusion. So initially here, I can see that we're working with the square of an odd number. Now I can kind of model any odd number in terms of an unknown variable. So the common one used here would be 2n plus 1. And that's going to represent any odd number. It can represent any odd number because 2n is always going to be even, a multiple of 2. And then if we add 1, it's always going to generate an odd number. Similarly here, we could have used 2n minus 1 or 2n plus 3, anything like that, but this is just going to be the easiest one to work with here. So I'm asked to prove that the square of an odd number, which we have here as 2n plus 1, so this is an odd number, we're asked to prove that the square of an odd number is always 1 more than a multiple of 4. So if I'm working with the square of this odd number, I'm going to start by squaring it. So if I take this and square 2n plus 1, I'm going to get the square of an odd number. So this is the same as writing 2n plus 1 multiplied by 2n plus 1, and then I can just expand out these brackets. So I'll do 2n times 2n, 2n times 1, and then 1 times 2n plus 1 times 1, using the FOIL method. So that leaves me with 4n squared plus 2n plus 2n plus 1, so 4n squared plus 4n plus 1 as this expanded bracket. And now if I'm looking to prove that this square, so this 4n squared plus 4n plus 1 is always 1 more than a multiple of 4, if I factorise out the 4 to get it in terms of a multiple of 4, I can then see what I have left over. So if I take this and take 4 lots of n squared plus n, and then I can add on this 1, leave this 1 separately at the end. Now this part of the expression here shows a multiple of 4. And then here I have a plus 1. So this is going to be 1 greater than a multiple of 4. So this way of writing the expression, 4 lots of n squared plus n plus 1 separately, is going to show that the square of an odd number is always 1 more than a multiple of 4, 1 greater than a multiple of 4. So I can just conclude by saying this is 1 more than a multiple of 4 as required. So now as for how the marks were awarded, the first mark would be for writing down an expression for an odd number, so 2n plus 1, 2n minus 1, anything like that. And then a second mark would be for expanding this odd number squared, so expanding these brackets and having at least 3 of the 4 terms there correct, which we do have. The third mark's for simplifying this, here in this line of working, to 4n squared plus 4n plus 1. And then the final mark is going to be for this concluding statement, so for writing that 4 lots of n squared plus n plus 1, and that's going to leave us with 1 more than a multiple of 4. And that's how each of the 4 marks are awarded for this question. So in this question, we're going to be working with surds and multiplying surds, and we have this equation here. So root 5 multiplied by, in brackets, root 8 plus root 18. And we're told that this can be written in the form a lots of root 10, where a is an integer, and then we're asked to find the value of a here. So when I'm working with surds like this and multiplying surds, I'm thinking about my laws of surds and how they're going to come in useful here. So if we're multiplying two surds together, the first thing that's coming to my mind is that, for example, if you had root a and you're multiplying that by root b, you could just write that out as the root of ab. So you can multiply surds in this manner. And that's going to come in really useful in this question. So if I write out the expression that I'm going to be working with, so root 5 lots of root 8 plus root 18. Now in order to expand this bracket, I'm going to multiply root 5 by root 8, and then I'm going to add on root 5 multiplied by root 18. So firstly, if I take root 5 and multiply that by root 8, and then add on root 5 multiplied by root 18, by what I've just shown, this law of surds here, we can basically take the 5 and 8 and multiply them together to get 40, and then put that under the same square root sign. And similarly, for the 5 and 18, that gets us root 90. So now we have these two surds that we're working with, and we want to get our answer in terms of a root 10. And these can be simplified, so we're going to simplify these surds and get them in some form of something root 10 so that we can add them together. Now by the same principle here, I can break these surds down into their factors, and if one of the factors is a square number, when I square root that, I'm going to get an integer. So here, if I want to work with a root 10, if I take root 4 and multiply that by root 10, 4 multiplied by 10 is going to get us this 40. We have the root 10 that we want to be working with in the question. And then we have the root 4, which is going to leave us with a square number. So the square root of 4 is going to give us 2, multiplied by root 10, which can't be simplified any further, to root 10. And then similarly here for the root 90, we can do the same thing again. So root 9 multiplied by root 10 gets us root 90. The square root of 9 is going to be 3, and then we have the root 10. So now we have two surds which are all linking to this root 10 which we want to work with, and now we just need to find a. So if we have 2 lots of root 10 and we're adding on another 3 lots of root 10, that's going to leave us with a total of 5 lots of root 10, so 5 root 10. And then just to note here, we're asked to give a, and a is just this integer before the root 10. So in order to get the mark here, I simply have to write down 5. Writing down 5 root 10 wouldn't get the mark in this instance. So if I go back through and have a look at where each of the marks were awarded, firstly, we'd get the first mark for either writing down root 40 or root 90, and then the second mark would be for simplifying this even further and getting to the 2 root 10 or 3 root 10 that we're working with. And then the final mark would be for the correct final answer here at the end of 5. And this has to be 5. 5 root 10 in the answer box would only get us 2 of the marks for the working out part of this question. So here I'm told that y is inversely proportional to d squared when d is equal to 10 and y is equal to 4. I'm then told that d is directly proportional to x squared when x equals 2, d equals 24. And I'm asked to find a formula for y in terms of x, so linking these two equations together, and I'm asked to give my answer in its simplest form. So to start here, I'm just going to go back and write out and set up these equations and these proportional relationships just so I can see exactly what's happening here. So if y is inversely proportional to d squared, then y is going to be proportional to 1 over d squared. And I can rewrite this as y is going to be equal to some constant multiplied by 1 over d squared. And that just leaves me with y is equal to k over d squared. So that's going to be an equation for this first sort of relationship that we have here. And then the second one, d is directly proportional to x squared, so d is directly proportional to x squared. And I can rewrite that as d is going to be equal to some other constant, which I'm going to call capital K this time, and that's going to be multiplied by x squared. These two constants are going to be different, so this lowercase k and the capital K are both constants in this sense, but they're going to be different constants because we're working with different equations. Now, if I'm asked to find a formula for y in terms of x, I'm somehow going to have to link these two equations. So y is equal to k over d squared, and d is equal to k, capital K, lots of x squared. Now I can see that I have a d squared in the denominator here and a d here. So if I can work out this constant and this constant, I'm going to be able to find an equation where y is equal to something over d squared, and d squared is going to be in terms of x. So if I take my first equation, so I have y is equal to k over d squared. Now if I take the values that I'm given here, so when d is 10, y is 4, and substitute them in, so y is 4 is equal to k over d, which is 10 squared. And then I can multiply both sides by 10 squared, which is 100, and that's going to leave me with k is equal to 4 times 100, so k in this sense is going to be 400. And I can rewrite this equation. So therefore y is going to be equal to what we've just found out k to be, which is 400, divided by d squared, which is still an unknown. Now if I work out what d is going to be using the second equation, I can then substitute this back in and leave me with an equation simply in terms of y and x. So if I do the same thing here, d is equal to k, capital K this time, x squared, and substitute the values I'm given in. So this time I'm working with these values, so d is 24 and x is 2. So 24 is equal to capital K, lots of 2 squared. So k is going to be equal to 24 divided by 2 squared, which is 4. So this constant is going to be 24 divided by 4, so 6. And yet again, I can write that out. So I'm going to have d is equal to 6x squared. Now I've got these two equations here, y is equal to 400 over d squared, and d is equal to 6x squared, and I can simply substitute this equation for d into this d squared, and it will leave me with an equation in terms of y and x, which is what I'm looking for. So if I take my y being equal to 400 over d squared, and that's going to be equal to 400 over d, which I've calculated to be 6x squared, and that's all going to be squared. That's going to give me 400 over 6 multiplied by 6, which is 36, and then x squared raised to the power of 2. So we're going to multiply the power of 2 by 2 to give me x to the power of 4. Now this is an expression for y in terms of x, however it's not in its simplest form like the question required. 436 share common factors, they share a factor of 4. So if I divide this fraction by 4 over 4, which is just the same as multiplying it by 1, which doesn't change its value, and simplify this fraction, it's going to take me to 100 over 9x to the 4, and then that's going to be this formula for y in terms of x in its simplest form. So then I can just write out y is going to be equal to 100 over 9x to the power of 4 as my final answer here. Now as for how each of the marks were awarded here, if I go back to the start of the question, I gained a mark for setting up each of the equations. So for the first and the second equation that I set up, which is working with the proportional relationship, I gained a mark for each of those. I then went on to gain another mark for finding one of the constants of proportionality, so either lowercase or uppercase k in this sense. And then the penultimate mark, so the fourth out of the fifth mark, was for basically using a process to find y in terms of x. So here I substituted in the value of d being equal to 6x squared. And then the final mark is going to be for the correct final answer of 100 over 9x to the power of 4. And that's how each of the 5 marks in this question would be awarded. So to begin with here, I'm asked to factorise the expression a squared minus b squared. So I'm working with 2 different square numbers. These are just unknown variables, but it doesn't matter because we're just trying to factorise them here. So we want to basically write this as 2 brackets which would multiply out to give us a squared minus b squared. Now I've noticed here that we're working with these 2 different squares and we're working with the difference between them, so one subtract the other. And that's reminded me of the concept of the difference of 2 squares, often written as dots. And that's basically when we have 2 square numbers and finding the difference between them. The way that we factorise them is by taking a, so the first one, plus b, and multiplying that by the difference between them, so a minus b. Now if I take these brackets and expand them out, so a plus b, a minus b, if we use the FOIL method, so we can take these 2 multiplied together and then these 2, it's going to leave us with a squared plus ab minus b squared, and then the plus and minus ab cancel out, leaving us with a squared minus b squared as required. Now I'm keeping this idea of the difference of 2 squares in my head, ready for the next part of the question where it might come in useful. So now here I'm asked to, hence or otherwise, simplify fully this expression that we're given here. So x squared plus 4 all squared minus x squared minus 2 all squared. Now this phrase hence or otherwise is making me think back to the previous part of the question and how this idea of these 2 squares is going to link back to what we just did in the previous part here. So if I have a look at the brackets that we're working with, we have a square subtract another square, and although it looks a bit more complicated, it is again working with the difference of 2 squares. So if I were to write out it as so, we could write it out as a squared minus b squared. And in this instance, a is going to be equal to what's inside the squared brackets, so x squared plus 4. And b is going to be equal to what's in the second bracket, so x squared minus 2. So now we've set up a and b, and we can use this to simplify the fraction even more so, simplify these brackets. So as with before, we had a squared minus b squared can be factorised as a plus b multiplied by a minus b. Now we can take this and use it to simplify what we have here. So if I take in brackets a plus b, we have x squared plus 4 plus x squared minus 2. And we're going to multiply that by a minus b, so x squared plus 4 minus x squared minus 2. And if we expand out, if we add and subtract and take out the brackets, we're going to be left with 2x squared plus 2 multiplied by, so the x squareds here cancel out, and then we're left with 4 minus 2, which is 4 plus 2, so multiplied by 6 basically here. And that's going to leave us, if we multiply this out, with 12x squared plus 12. And then we could even factorise this to leave us with 12 lots of x squared plus 1, just to simplify that even further, but that's not necessary to gain the marks here. And then if I just write this in the box, that is going to gain us the third of the 3 marks for this question. So if I look back at how the marks were awarded here, the first mark would be for using a and b as these values that we've written out. So a is equal to x squared plus 4 and b is x squared minus 2. Then the second mark would be for using the a plus b, a minus b expansion type thing and substituting in the values. And then the final mark is going to be for coming to the correct final answer of 12 lots of x squared plus 1. As this question was a hence or otherwise simplify, we could have gone about it in a different way and expanded the brackets and worked with them this way and then done some more calculations with the values in the brackets once they've been squared, but that would have taken a lot longer and would have gotten quite complicated and easy to miss out terms. So in types of questions like these where there's a hence or otherwise, it's usually better to follow the method used in the previous question if that is possible. So here I'm told that there are only red counters, blue counters and purple counters in a bag. And I'm also told that the ratio of the number of red counters to the number of blue counters, so the ratio red to blue, is 3 to 17. I'm told that Sam takes at random a counter from the bag and that the probability of this counter being purple is 0.2. And I'm asked to use all of this information to work out the probability that Sam actually takes out a red counter. So initially here, I'm thinking that if we have the 3 colours of counter, the red and blue and purple, if we know the probability of him picking a purple counter out, then we also know the probability of him picking either a red or a blue counter out. So the probability of red or blue is simply going to be 1 minus the probability of the counter being purple, because those are the only 2 other options, red or blue. So we can do 1 minus 0.2, and that gives us 0.8. So the probability of the counter being red or blue is going to be 0.8. And then we can then go on to use this when we link back to the ratio. So if we have the ratio of red to blue, if I just write this out again, which is 3 to 17, we can work out the probability of, within this ratio, the counter being red. And then we can multiply this by the 0.8 to find the probability of the counter being red overall, not just within this ratio. So the probability of it being red here is going to be 3 out of the sum of 3 and 17. So the total of this kind of ratio here. And that gives us an answer of 3 out of 20 for the probability of it being red within this ratio. Now the probability of it being red overall, so this is including the purple counters again, we're going to take the 3 over 20 and multiply it by the 0.8 probability of it being either red or blue, and that comes out with an answer of 0.12 for the probability of Sam picking a red counter. Now if we think back to the numbers in the question, this does sound about right. It feels like it's within the right sort of range and definitely has potential to be the correct probability here. So as for how the marks are awarded here, you get 1 mark for kind of starting off this process and working with the probability of it being red or blue and with the ratio here. So working with both of these things, either in 1 or 2 separate calculations, brings us the first mark. Then working further with the multiplication to find the probability of it being red overall. So this 3 over 20 multiplied by 0.8 part would gain us a second mark here. And then finally, the last mark is going to be for the correct final answer at the end of 0.12. So here I'm asked to simplify fully the following fraction. So we have 3x squared minus 8x minus 3 all over 2x squared minus 6x. So when we're working with simplifying fractions like this, the first place to start is always going to be factorising out the numerator and denominator and then seeing if we can cancel any of these brackets that we've created by factorising. So a way that I always go about doing this is by looking at the numerator and denominator and seeing which one looks easiest to factorise. Now looking here at the denominator, as you can see, we've got a common factor here so we've got x in both the 2x squared and the minus 6x, and also both will divide by 2, so we could take the 2x out and factorise it this way. And I think that would be a good place to start because it's going to be quite an easy way to factorise it, and then we can look back to the numerator and see if we could possibly use one of the factors that we've taken from the denominator to factorise the numerator more easily. So here if I take 2x squared, I take out the 2x. In order to get 2x squared, I'll multiply that by x, and then in order to get 6, I'll multiply that by 3. So I'm doing the x minus 3, and this will multiply out, so 2x multiplied by x is 2x squared, 2x multiplied by minus 3 is minus 6, and that gives us the 2x squared minus 6. So now that I've got this part, looking back to the numerator, I need to work out if I could factorise this in a way that it's going to share one of the factors that the denominator has so that they can cancel out. And if I look at the x minus 3, this links with the minus 3 up here. And a way of thinking about this would be if I had the x minus 3, what would I need to multiply it by to get to 3x squared minus 8x minus 3? Well, to get the 3x squared, I need to multiply it by the 3x. So that would give me 3x squared when the first term in each bracket is multiplied by one another. And then to get the minus 3, I'm looking at the last terms in the brackets. So what does this minus 3 need to be multiplied to get minus 3? And that's going to be 1. So I can add 1. And then I can just check this works. So we'd have, if I expanded this out, we'd have 3x squared add x minus 9x minus 3. And that would give us 3x squared minus 8x minus 3 when simplified. So that is going to be correct here. So now moving on, I can see that I have an x minus 3, which I wanted to happen in both the numerator and the denominator. So I can simply cancel these out, divide the top and the bottom of the fraction by x minus 3, and that's going to leave me with a simplified fraction of 3x plus 1 over 2x. Now, although there is an x term in the numerator, this term is just a plus 1, so there isn't an x term there. And we can see that there's no way of simplifying this fraction anymore. So this 3x plus 1 over 2x is the simplified version of this fraction, and we've answered the question correctly. So as for how the 3 marks are awarded here, the first mark and the second mark are both for basically factorising out these equations at the top. So we'd get the first mark for either breaking the numerator or the denominator down into its correct factors. And the second mark is going to be for getting both the numerator and denominator factorised correctly. And then the third and final mark is just for writing the answer down in its simplified form, which we have here. So here we have the graph of y equals sine x for values of x between minus 180 and 180. And then we can see that here, so the graph starts there and ends there between these values of minus 180 and positive 180. There's x values for all of these values in between. And then we're asked to, on the grid, sketch the graph of y equals sine x minus 2 for x values between minus 180 and positive 180. Now, when we're working with graph transformations, I always start by looking at whether the transformation is going to be in the x or the y axis. Now, as this is written here, we could basically bracket this sine x off just to make sure it's a bit easier to see and we don't think the minus 2 is involved with the x. So if we have y equals sine x in brackets minus 2, we're going to have a transformation in the y-axis. Now, the transformations in the y-axis happen as you think they're going to, so a transformation of minus 2 is going to mean that the graph shifted down the y-axis by 2, so minus 2 in the y direction. Whereas if we were working with a shift in the x direction, it kind of works opposite to what we may think that is going to happen. So if it was x minus 2 in brackets, then it would actually shift 2 to the right as opposed to 2 to the left, which we may think it might. But we're working with this transformation in the y-axis, so a shift downwards of 2, a shift of minus 2. So we need to basically move this curve down by 2. So a way that I like to do this is go through and plot some key points just to make sure that I can draw a smooth line through all of them. So if I take, for example, the origin point, I'm going to need to move this point on the graph down by 2, and that's going to go to the point of 0, minus 2 here. So I can just plot that on. And then similarly, if we go back to the start, this point is at 0, we're going to move that down by 2 as well. And that gets us to here. Then the centre of this curve here is at minus 1, so we subtract 2 and get to minus 3, which is going to be here. And I can plot that one on as well. And then I can just do the same with any more key points here and here. So I can now just draw this curve in through all of the points. And that is the graph of y equals sine x minus 2. Now, to gain the marks here, I gain a first mark for a translation in the y direction. So but for moving this graph down in the y direction, I'll gain the first mark, and then the second mark of the two is going to be basically for the correct graph. So the graph translated by minus 2 in the y direction is going to gain me that second mark. So in this question, we're told that the point P has coordinates 3, 4, and that the point Q has coordinates A, B. We're then told that a line which is perpendicular to PQ is given by the equation 3x plus 2y is equal to 7, and we're asked to find an expression for B in terms of A, using all of this information we've been given in the question. So if we've got the coordinates of P and Q on the line PQ, we could use these to work out the gradient of PQ in terms of A and B. And that might come in really useful if we can work out what the gradient of PQ is using another method as well, possibly using the line perpendicular to PQ, and then we can make them equal to each other and work with those to get an expression for B in terms of A. So if I start by looking at the line that's perpendicular to PQ, and that's given by the equation 3x plus 2y is equal to 7. Now, it's always a good idea to get equations of lines that are in a bit of a more complicated form into the form of y equals something so that they look a bit more familiar and easier to work with. So if I subtract 3x from both sides of this equation, and then I can divide both sides of the equation by 2. And that leaves me with an equation in the form of y is equal to mx plus c. Now I've basically calculated the gradient of this line that's perpendicular to PQ. So the gradient of this line, m is equal to minus 3 over 2. Now if this line is perpendicular to PQ, the gradient of PQ is going to be the negative reciprocal of this gradient, because the gradients of two perpendicular lines multiply together to make minus 1. So if I take the gradient of PQ I need to take the negative reciprocal, so minus 1 divided by the gradient of this line here, and that's going to give me a gradient for PQ of 2/3. So now that I've got a numerical value for the gradient of PQ, if I work out the gradient in terms of A and B, then I can use these and make them equal to each other to find this expression for B in terms of A. So the gradient of PQ is going to be equal to the change in Y over the change in X values for the line PQ. So if I take the points at Q, so Q, the coordinates are A, B, and P, the coordinates are 3, 4. So I take the Y coordinates, firstly, and do the change in Y coordinates, the difference between the two, so B minus 4, and then do that over the difference in the X coordinates, so A minus 3. That's going to get me the gradient of PQ. So the gradient of PQ in terms of A and B is B minus 4 over A minus 3. Now, this is obviously going to be equal to the gradient we've calculated here, so the 2/3. So I can set up an equation making them equal to each other. So B minus 4 over A minus 3 is equal to 2/3. And then to simplify this, I can cross multiply. So multiply the 3 by B over 4, B minus 4, and multiply A minus 3 by 2. And that is going to give me 3 lots of B minus 4 is equal to 2 lots of A minus 3. So 3B minus 12 is equal to 2A minus 6. And then if I want an expression for B in terms of A, I can add 12 to both sides firstly to get me this. And then I can divide both sides by 3 to leave me with B is equal to 2/3 A plus 6 divided by 3, which is 2 here. And that is going to be the correct final answer to get us the final mark here. B is equal to 2/3 A plus 2. Now if I go back and have a look at how the marks were awarded here, I would have gotten the first mark for rearranging the equation up here to get Y in terms of X to start off this process. And then for using its gradient and finding the negative reciprocal of it, that would give me the second mark. So basically the two gradients have to multiply to -1, so we could have set up an equation there to figure this out, but this would get me the second mark here. And then the third mark is going to be for a process to find the gradient of PQ using A and B, so finding that B minus 4 over A minus 3 is the gradient. And then the fourth mark is for setting up an equation where they're equal to each other, so these two gradients are equal. And then the fifth and final mark is going to be for this correct final answer of B is equal to 2/3 A plus 2. So here we're told that n is an integer such that 3n plus 2 is less than or equal to 14, and that 6n over n squared plus 5 is greater than 1. And we're asked to find all of the possible values of n. Now, just to remind me later on in the question, I'm just going to write down that n has to be an integer here. So we're just going to be working with integer value solutions for this. We're not going to be looking at any sort of inequalities later in the question. So as for how I'm going to go about starting this question, we obviously have two inequalities that we're going to work with and find values of n that are going to satisfy both. And working with inequalities, especially with quadratics and linear inequalities, we're probably going to need to sketch these graphs. And in order to aid us with this, simplifying these inequalities and getting them in terms of the unknown, so n in this case, is going to be really helpful when seeing which values of n are going to satisfy them. So if I take the first inequality, so 3n plus 2 is less than or equal to 14, to get this in terms of n, if I firstly subtract 2 from both sides, so that leaves me with 3n on the left, and then 14 minus 2, which is 12, on the right. And then I can simply divide both sides by 3, So n is less than or equal to 12 divided by 3, which is 4 here. And that's basically my first inequality written in terms of n being less than or equal to something. So then working with the second one, the same sort of principles apply here. So 6n over n squared plus 5 is greater than, this time, 1. Now I can multiply both sides by n squared plus 5, and that leaves the left-hand side as simply 6n. And that's 6n being greater than 1 multiplied by n squared plus 5, so n squared plus 5. Now I can see that I'm kind of sort of building a quadratic here. We've got an n squared and a term with n in it. And if I move all of the terms over to one side of the inequality sign, I'm left with basically a quadratic being less than 0. So if I move the 6n to the other side, I have 0 is greater than n squared minus 6n, because I'm subtracting it from both sides, plus 5. Now in order to find the roots of this equation, so the values of n, the values that basically intersect the n-axis of this graph, which could be basically changed to x, it's the same sort of thing, I'm going to factorise it. I could use the quadratic formula here, but this is going to factorise really nicely. So that's going to leave me with n minus 5 multiplied by n minus 1, and that is the factorised form. Now I can see that if we make either of those equal to 0, the roots of this equation are going to be where n is equal to 5 and n is equal to 1. So basically this holds for values of n between 1 and 5. Now, when I'm working with inequalities, the best idea to go on from here is definitely to sketch the graph in, just so we're 100% sure of what we're working with and where all of these values are going to sit. So if I draw some axes of a graph in, now the y-axis is just going to stay as the y-axis here, but then I'm just going to label the x-axis as n, because that's our unknown variable in this sort of question. So then, working with this inequality to begin with, if we have solutions at n equals 5 and n equals 1, I can just plot those on the n-axis, so n equals 1 and then n equals 5. And we're working here with a positive quadratic because the n squared coefficient is 1, which is positive. So it's going to be a positive quadratic, so like a smiley face, as opposed to a negative quadratic or a frown. So I can just sketch that in. Doesn't matter where the turning point is or anything like that, we just need a rough idea of the inequality. And then also here, I'm looking for where this quadratic is going to be less than 0. So any values of this quadratic that are less than 0. So we take the value for 0 on the y-axis, and we're basically looking at all of these values that sit below the y-axis but aren't equal to it. So 1 and 5 aren't included, but this region here is. So I can write this as an inequality. 1 is less than n, which is less than 5, when working with this inequality we have here. Now similarly, I can now draw in the other line of where n is less than or equal to 4 to see which values of n satisfy both inequalities. So n is less than or equal to 4 is simply going to be a straight line that runs parallel to the y-axis, and this is going to be at the point 4. And we're looking for anything this side of this line, so less than or equal to 4, and it is including 4 here. So now we're looking for the points at which n satisfies both of these inequalities. So the points that sit on this line here, but are also to the left of this line n equals 4. So that's going to be this part of the curve here. And I remember that we're looking for integer values in this question. So if I go from 1 to start with, 1's not included because it's just the greater than symbol, it's not greater than or equal to. Moving up, 2 will be included, 2 is less than 4, so is 3. And then moving up still, 4 is going to be included here because it is less than or equal to 4, so we can include 4. However, anything beyond 4, anything greater than 4, so 5, is not going to be included in this inequality because n is not going to be less than or equal to 4. So here we have our 3 integer values, 3 possible integer values that could represent n, and that is going to bring us to the end of this question. Now if I go back to see how the marks were awarded here, we gained the first mark for basically solving the first inequality and getting that in terms of n, so n being less than or equal to 4. And then the second mark for rearranging this inequality here, so multiplying out and getting it in the form of a quadratic, so this quadratic here. And then the next mark was for factorising this, so leaving us with n minus 5, n minus 1. And then for forming some kind of inequality, so for n being greater than 1 and n being less than or equal to 4, or for this inequality that we've written out here. And we've represented this graphically in the diagram that I've drawn up. And then the final mark is going to just be for this correct answer of 2, 3 and 4 as the integer values for n.